Alright, in our previous lectures, we have learned pre-order traversal and in-order traversal, and we have created functions using Java programming language. Now here, we will look at another type of traversal, which is post-order traversal. So in case of in-order traversal, we were visiting first left subtree, then root, then the right subtree. Now in case of post-order traversal, we are going to traverse through first left subtree, then the right subtree, then the root node. So the algorithm will be like this. First we are visiting all nodes from the left subtree, then we are visiting all nodes from the right subtree, then we are visiting the root node. So in this case of binary tree over here that we have, the left subtree is this part. So first we have to visit all nodes from this part, then the right subtree. So the same logic will be applicable over here. We are visiting all nodes of right subtree, then we are going to visit root node. Now if we start from the left subtree over here, we see that inside this left subtree, we have another left subtree over here. So this means that we have to first start from this smaller left subtree over here. So here, the same logic will be applicable. So which means that first we are going to visit left subtree. So in this case, we have only one node over here, which is left child. So the left child of this smaller left subtree is N8. So this is the first node that we are going to visit. Now after visiting N8, we are going to continue to the right subtree. So in the right subtree, we have only one child, which is N9. So this is going to be the next node that we are going to visit. Now after visiting the right child, we are going to continue to the root node. So the root node of this smaller left subtree is N4. So this means that the next node that we are going to visit is N4. Now after finishing this smaller left subtree, we are going to continue to the right subtree of this bigger left subtree. So the right subtree of this bigger left subtree is N5 because we have only one child over here. So the next node that we are going to visit is N5. Now after finishing right subtree, the next step is we need to continue to the root node. So the root node of this left subtree over here is N2. So the next node that we are going to visit is N2. Now after finishing this whole left subtree over here, the next step is we need to continue to the right subtree. So we have a right subtree over here. In right subtree, we have left and right child. So this means that the first thing that we are going to do, we are going to visit left child, which is N6 in this case. Then we are going to visit right child, which is N7 in this case. Then we are going to visit the root node of this right subtree, which is N3. Now after finishing right subtree, the last step is we need to visit the root node. So in this case, we are going to visit N1. Now you see that in case of in-order and pre-order traversal, the last node that we were visiting was N7, because in that case, the last node that we are visiting is the rightest node of the right subtree. But in case of post-order traversal, the last node that we are visiting is N1, which is the root node of this whole binary tree over here. Now if we combine all steps over here, the order of visiting nodes of this binary tree in case of post-traversal will be like this. First, we are going to start from the left subtree's leftest node. So in this case, N8, then N9, then N4, then we are continuing N5, then we are continuing N2, N6, N7, and N3, and at the end of the root node of this binary tree, which is N1. Now with this, we have completed visiting of all nodes of this binary tree in case of post-order traversal. Now based on this logic that we have discussed over here, which says that first we have to visit all nodes of left subtree, then the right subtree, then the root node, we are going to implement a method in Java for post-order traversal of binary tree. So let's head over to Java to create our method over there. Now inside this binary tree class that we created before, we are going to create post-order traversal after in-order traversal method. So here I'm going to declare our method like this. So it's going to be void post-order. So as always, it's going to take as a parameter the root node. So in this case, it's going to be the type of the binary node. So I'm going to put it binary node, the node. Then the first thing here again, we are going to check the base condition. So whenever our parameter, the node over here is null, in this case, we are going to return. So I'm just going to copy it from in-order traversal and pass it over here. So this is going to be our base condition in this case. Now here, as we mentioned before, we are going to start looping through the all nodes of left subtree. So this means that I'm going to call post-order traversal for left subtree. So it's going to be like this, node.left. Then after finishing all nodes from the left subtree, we are going to continue to the right subtree. So we have to visit all nodes of right subtree in this case. So this means that I'm going to call post-order traversal for right subtree. Now after finishing right subtree, we are going to visit the root node. So in this case, I'm just going to print out the value of node. So in this case, we are visiting the root node in this case. So here we have successfully completed our post-order traversal. So basically the logic is first we are visiting the left subtree, then we are visiting right subtree, and at the end we are visiting the root node of this binary tree over here. Now based on the binary tree that we created before, as you remember, I have created these nodes manually and I have created a link between them. So in this picture, you can see that this binary tree that we created over here, and here we are showing the order of nodes in case of post-order traversal. So instead of calling in-order traversal, I'm just going to call post-order traversal to see that if this order is same as the order that we have explained in our slides. So if I run our code, you'll see that first it starts from the leftest node, so which is the N8, then it continues to the right child of the smaller left subtree, which is N9, then it continues to the root node of smaller left subtree, which is N4, and it continues like this, then the right child, then root node, and it continues like this until we reach the last node, which is the root node in this case. Now in this case, you can see that this output is same as the output that we have in our picture over here. Now with this, we have successfully implemented post-order traversal. Now let's see what's the time and space complexity for this method over here. So here again, the first thing that we are going to do, we are going to start from the first line of this method. So in the first line, we are checking that if this node is null, then we are returning. So this means that these 2 lines of code over here will take a 1 time complexity, because here time consuming operation is not performed. Now in the next line of code, we are calling post-order traversal method recursively for the left child. So in this case, this will take on divided by 2 time complexity, and we have discussed this case in our recursion section. So if you are interested, you can go back and watch there. And the next line of code also will take on divided by 2 time complexity. Then the last line of this method will take a 1 time complexity. Now if you combine all these complexities over here, we will get on time complexity. Now the space complexity is also on, because in this case, whenever we are calling a function recursively, we are inserting these nodes to the stack memory to remember the next step. So this means that all nodes will be inserted to stack memory. So that's why whenever we are calling this method, it will take on space complexity. Now with this, we have completed this lecture. So in this lecture, I have discussed the logic behind the post-order traversal, and we have implemented it in practice. So hopefully everything is clear about this lecture. So see you in the next lecture.